So in the previous day, we looked at inelastic collisions when things stuck together. Elastic collisions are a bit more challenging to solve for, or can be, because it's more algebraically intensive. So the main difference between inelastic and elastic collisions is that elastic collisions, both momentum and energy is conserved. So if we look at this first question, we have two objects. As initially, we have object A traveling towards object B. We have the speeds listed, so the mass is listed, and they're going to bounce off each other and going to go in different directions, most likely. So we need to figure out what are those two speeds. So how we go about that is we're going to first look at momentum. So look at momentum first. Okay. So what is happening with momentum? This is a 1D problem, so you don't have to worry about up, down, left, right, but we can imagine it's going to be quite intensive algebraically if we have two dimensions as well. So we have, let's see, before we have V1 and mass A. So momentum is 2 times 0.5, that is 1.0 kilograms meters per second. So all I did there was go P is equal to mass times velocity. So object A, we have 2 times 0.5 is 1. Now object 2, we're going to add the momentum of object B, but it's negative, so we have 2 times 0.3. It's negative, we get negative 0.60 kilogram meters per second. And that's the left side. So this is just like what we did in the earlier days of this topic. Now afterwards, we don't know how fast V3 or V4 is. We don't actually know what direction it is. So I'm going to write down 0.5 because the object A is 0.5 kilograms. And I'm going to put a V3 right there because that's what I called it, V3. Okay, I'm not going to write down any negatives or positives. So when I solve for this, if V3 comes out to be a positive number, it actually means it's moving to the right. If V3 comes out to be negative, it means yes, it's going to move to the left because we are assuming that right is positive direction. So plus 0.30 kilograms times V4. So write this out, we say can't solve it, there's two unknowns. But what we can recognize is that we can have a second equation for energy. So before I do that, let's simplify this down a bit. 1 minus 0.6, that is 0.4. And 0.50, can't simplify it too much yet. Okay, so there's our equation. Now let's see what happens for energy. For energy, the equation for energy is kinetic energy, 1/2 mv squared. So you're going to have 1/2. Mass is 2 kilograms multiplied by, that's right, so 2.0. Oh, shoot. Sorry, let me erase that. Our mass is 0.5 kilograms. Our speed is 2 meters per second. We're going to square that. And the energy of the second thing, we have that 1/2. 0.30 kilograms times the speed of 2.0 meters per second. And I don't really care if it's positive or negative because it's just, when I square it's going to become positive anyways. And that's equal to 1/2 0.50 kilograms times some unknown speed squared plus 1/2 0.30 kilograms times V4 squared. So some numbers are going to cancel. Well, first of all, the halves all just cancel out because there's a half in every single term. So we can see that 2 squared is 4, half 4 is 2. So we get 2.0 joules plus 1.2 joules is equal to 0.50 V3 squared plus 0.30 V4 squared. So I should have kilograms there as well. And 2 0.0 plus 1.2 just adds up to be 3.2. To get 3.2 joules. So here's our second equation. Now it's just a matter of lots of algebra. So equation 1 and equation 2. So I'm going to take equation 1 and rewrite it. For it doesn't matter, V3 or V4. So I'm going to solve for V3 and divide every term by 0.5. So 0.4 divided by 0.5 is equal to 0.8. And 0.3 divided by 0.5 is 0.6. I'm going to subtract the V4 term, so I got minus 0.6 V4. Now I'm going to plug equation 1 into equation 2. So equation 2 is 3.2 is equal to 0.5. You have 0.8 minus 0.6 V4. That's going to be squared. Now we have minus 0.6. That's right. That's actually 0.3. V4 squared. Okay. Again, if you can't see it, all I did, this is V3. This is V3, and we plugged it right into V3. Okay. So the equation is exactly the same, but V3 has been replaced by 0.8 minus 0.6. And now it's just a matter of solving this quadratic equation. So when we simplify this equation down, we end up getting, well, I first have to first expand this bracket, multiplied by, so square this whole thing, multiply by 0.5. After simplifying, all said and done, you end up with the equation 0.48 V4 squared minus 0.48 V4 minus 2.88 is equal to 0. And we use the quadratic formula. So we actually end up with two answers for this one. So I know it's getting a little crowded, but when we solve for this using the quadratic formula, we end up with two equations. We have two solutions. V4 is equal to 3.0 meters per second, but it's also equal to negative 2.0 meters per second. So when we solve for this one, 1 is actually our original value. So notice how object V was originally traveling at negative 2 meters per second. It's not going to be that one. That was the original speed. So V4 is going to travel at 3 meters per second after the collision. When we plug in V4 into either of the equations, we get V3 is equal to negative 1.0 meters per second. And we are done.